All right, everybody. So we are going to be going through practice number 6. Um, so this, like I said in the other video, this is a kind of a longer free response question that's going to be at the end. And if you keep that pace of 12 minutes for the first 5 questions for each of those, then it's going to give you about 30 minutes to work on this. So the reason that you want to give yourself more time for this is because um, there's more parts to the free response question. You're pulling information from a lot more parts of the school year. So like Unit 1, Unit 2, Unit 3. Um, and then also it's kind of asking you to do things to take it to like the next level. Like in this one that you just been working on, you see how to come up with some formulas on your own, like create your own formulas. That's something that it would come up on these number 6 problems. Something where you like come up with a specific statistic to measure something. So yeah, I'm just going to walk you through this just to kind of show you how to do this problem. I'm also going to post a couple extra number 6 practice problems on the website. So you can use that over the weekend to get some extra practice if you want. But these are obviously probably the more challenging ones because they give you the most. You want to spend the most time on it. Try to get through as much as you can, but sometimes the different parts aren't connected to each other. So if you get stuck on one part, go to the next part and maybe come back to that part later. And finishing the rest of the problem might help you with that initial part that you had to miss. All right. So basically, we're starting off with this scenario where this person wants to test to see if this company's claim of 27 miles per gallon is right or not for this car. So part A, if we're thinking about what this came from, this is from our regular significance test, one sample unit, which was unit number 8. Nope, unit number 9. So unit number 9. So you just had to write what the parameter interest is, which remember the parameter interest is what you're measuring, right? So our parameter interest is the mean, the true miles per gallon of the car model. All right. So our null hypothesis that is there's not difference from what the claim is. So our null hypothesis would be our mean equals 27 miles per gallon. Remember, we always use the population mean symbol, the U, not the X bar sample mean for these proportions. So always use the population U symbol for the mean, and then the P symbol without the P hat for the proportions. Anyway, so your null hypothesis should be your mean equals 27 miles per gallon. Your alternative hypothesis should be mean is less than 27 miles per gallon. And that's because we think that they're overestimating. So we're trying to prove that it's less than 27 miles per gallon. That's part A. Okay, that part was pretty straightforward. Now it says one condition is for one sample t-test is that our measurements should be normally distributed, which is correct, right? We want to make sure that it's normally distributed, right? So they have a box plot and a histogram for the data set, and we see that there's a pretty strong skewness to that. But we just have a sample of 10, right? So it's going to be hard for us to know for sure if we just have a sample of 10. So then it says one possible measure statistic. So this is like a formula that they came up with to measure skewness is the sample mean divided by the sample median. So remember, the skewness is going to affect the mean. It's going to, if it's skewed to the right, it's going to drag the mean higher. If it's skewed to the left, it's going to drag the mean lower. And then the median is resistant to that. So if we're skewed to the right, that means that our mean is going to be higher than what our median is. And that means that if we put it into a formula, a higher number than 1 is going to be saying that we're skewed. All right, if it's symmetric, then our mean and median line up together. When we divide those, it comes out to 1 if they're the same number, right? So if it's going to be larger than 1, it's going to be skewed to the right. And then if we had a situation where it is less than 1 with this statistic, that means it would be skewed to the left. But in this case it's skewed to right, so it's going to be larger than 1. So again, when I'm looking, writing my answers, look how concise it is, right? Because I don't got a lot of time on this test. I time myself when I do this too, to kind of put myself in your shoes when you're on the test, right? So you want to make sure you're writing concise and make sure everything's clear, right? I answered that. Everything I needed to put was in one sentence there for part B. So then they did this simulation, so sampling distribution, of 100 different times to see what would that be for the sample statistic. So this is like essentially what we did with the tank activity way back beginning of this semester. We were in that simulation. So it's asking based off this and this dot plot that we came up with, is it reasonable that we could say it's approximately normally distributed or plausible? So if it says plausible, it's not saying more definite that it's normally distributed, but there's a chance, right? So if we had our sample of 1.03, there are 14 values above that. So essentially, if it was really symmetric, normally distributed, and our center was at 1.0, then there's a 14% chance that we would get a value of 1.03 or above in our sample, okay? Which is a lower percentage, but it's not below that 0.05 that we're looking for anytime we're dealing with something significant or not. So, and especially since it just says it's a plausible, since it's not a super low percentage, we have evidence to say that is plausible, right? We don't know, definitely not evidence that it is normally distributed, but it's plausible. And that's usually what we're trying to do if it's normally distributed or not. So based off the simulation dot plot, we can say that it's plausible because they are 14 values in the simulation above 1.03, so it's normally distributed. That is a 14% chance that we would get a result at or above 1.03. Notice how here I wanted to save some time, so I just crossed out a couple things. That's totally fine. You're not going to lose points for like crossing stuff out if you don't want to worry about like erasing it. Just make sure it's clear. As long as they can read what you're saying, it's clear to them, you're going to get your points. So then it says come up with another summary stat using the table here to measure skewness. So we have five summary stats: minimum, Q1, median, Q3, maximum. So now you got to come up with some form of statistic that's going to measure skewness, right? So if we're thinking about a box plot, skewness means that from the center, the median, to the end of the whisker, one would be longer than the other, right? So I made up this formula where you had the maximum minus the min. That's going to measure that right half of the box plot, and then divided by the median minus min, which is going to measure the length of the left side of the box plot. All right, so then it's essentially going to be the same as the other formula that they gave us. If we have a positive value, that means that the right is longer than the left, which means it's going to be skewed to the right. And then if it's a lower value than 1, that means it's going to be skewed to the left. All right, so I said a larger value would indicate skewness to the right. So there's a couple different options they could have come up with. That was the one I came up with and the one that the AP test rubric was the one they put down for their answer. But if you have another one that you think works and you're not sure if it works or not, and want me to look at it, feel free to just email it to me and I'll let you know if that one works or not. So yeah, you can see that for this number 6, you got some more parts to it, and it's really kind of taking your knowledge into kind of like the next level, coming up with formulas, kind of taking it that analyst part to the next level. All right, so I recommend just either in your Princeton review book or on the website, trying to go through a couple more of these before the AP test just to get a little bit of practice and getting comfortable with them.